Hello everyone. Today we will be looking at discrete random variables. In discrete random variables, the things we are going to study are the following. First of all, we will be looking at what is a random variable, an example of random variables, some type of random variables. Then we're going to look at some distributions and then find the mean and standard deviation of discrete random variables. So before I start with the random variable, let me talk about some things we have done earlier. The first thing we're going to talk about is probability. Now recall, probability is used in quantification of uncertainty. We have looked at probability of some events. We talked about events which are disjoint, events which are independent, complement of events. Then we also have looked at conditional probabilities, looked at how to have a graphical representation of these, some of the events in the form of a Venn diagram or a tree diagram. So we have looked at various ways of it. Now, here we are going to look at some probability models. So in a probability model, we would like to describe the distribution of the values of a variable. So as I said, we're going to look at some probability models. Now these probability models, and I'm talking of the session today we are looking at, here we're going to talk about these probability models. They will describe the distribution of the values of the variables, and these are the random variables. So I'm just giving you a little overview of what things are going to be happening. But remember, everything is concerned with some form or the other probability here. It's the study of uncertainty. And now we're going to look at some of the concepts, the basic concepts, as the first one we're going to talk about here is a random variable. So what is a random variable? A random variable, it is a quantitative variable whose value depends on chance. Remember, probability is a chance. So what are we looking at is a variable whose value is depending upon chance, and that's where the randomness comes out. Okay, we use this random variable to describe the behavior of populations. And the randomness is coming from selecting a random sample for a population, or we are performing some randomized experiments. Now we're going to use some notations here. The notation which we're going to follow is, we're going to use capital letters for random variables and a lowercase letters for the possible values. So here is a big overview of what is a random variable. Now we're going to look at a very simple example of a random variable. Okay, so we all know flipping of a coin. Okay, so let's start with things we have learned in probability. Suppose a coin is flipped 3 times. Okay, so when a coin is flipped 3 times, in probability, what did we talked about? We said, oh, what is the sample space of flipping of a coin? Okay, so sample space is, you will have 3 heads, like, in 3 flips, all the time the heads popped up. Then we had 2 heads or a tail, or a head tail, or a head, a tail, head, and a head. Okay, then there's a possibility of getting two tails and a head, a tail, head, and a tail, a head, tail, and a tail, and finally, three tails. Okay, so let's see how many possible outcomes we have in this flipping of a head coin 3 times. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, now that's easy over here. Now suppose if I was going to flip a coin, say 10 times. Now, would you like to write the sample space? No, I would not. It's too much. It's like, just to give you a heads on, so if I'm saying, oh, let's look at the sample space of flipping a coin 5 times. Okay, I'm just going to write 1 or 2 of them. So 5 coins, suppose the coin is flipped 5 times. 1, 2, 3, 4, 5. Okay, now one other possibility could be head, 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 tail. Now there are going to be 32 possibilities, I can tell you that here. Okay, I will be tired writing it down. So I'm saying, is there some other way to look at it? Okay, and that's where the random variable is going to come up. So what we're going to say is, hey, let's have a capital X, okay, that's a random, the number of heads in 3 flips of a coin. Okay, so the same sample space is going to be written in a very short form, but it will give all the information if we were doing literally writing down every possible outcome in that 3 flips. Okay, so what we say is, okay, let X, okay, the green one I'm using, so that I am going to write this whole information in very short form. So I say, let X be the number of heads in 3 flips of a coin. Okay, so when you have 3 flips, number of heads appearing. So let's look at this one. What happened? Triple head means how many times the head has appeared. So here, I'm going to write down the numbers. So here, this X has appeared 3 times, okay? So here, the flipping of the coin is showing that the head has appeared 3 times. Okay. Now, let's look at the next 2. What do you notice? These 2 are showing that the head is coming 2 times. So here, this X is going to be now 2. So this X is going to be my 3. So these are the various variables here, you know. Okay, let me write nicer one here. Okay. So this event or the outcome in the sample space says X is 3. And this one says this capital X, that means there are 2 heads appearing. What about, oh, there's another one, I forgot. So this one also 2 heads. So these 3 are showing 2 heads are appearing. The next 3, TTH, THT, HTT, they're showing that the head is appearing 1 time. When the last one, what does this show? It says the head is appearing 0 times. So notice, instead of writing down this whole sample space individually, all the outcomes in that sample space, we can say, hey, X, so all the sample space we're saying X is the number of heads in 3 flips of a coin. And what are the values my capital X can take? So the capital X, according to this, the possible values of this random variable, this capital X is a random variable. Remember, we talked about, we denote a random variable by a capital letter. So possible values of this random variable is what are those possible values of this random variable X? this x can be 3, can be 2, can be 1, and 0. So all the sample space, which we had to literally write it down, is written in this 3 in this little short form. So here, notice, is the very important information about random variables. This example shows why we would prefer to have an explanation using this random variable than literally writing down everything by hand. So that's why we are studying, guys, random variables. Okay? So random variables basically, you could have 5 flips of a coin. When you have 5 flips of a coin, now if I do not have to write down all this information, what I can do? I can say, hey guys, what I'm going to say is this whole sample space can be written in this form. We can say, let x be the number of heads. You can also say number of tails. It doesn't matter. It's basically going to be the same. Either it's going to be a head or a tail when you flip a coin. So I'm going to say, hey, x is the number of heads in 5 flips of a coin. So basically, this whole random variable, now all this information is written by one little sentence. And then on top of that, it says, okay, what are the possible values? Because if you have to show down each one of them, we can say, okay, when you flip a coin, what does this random variable can take? This random variable can have all the flips to be 5, or this random variable can be 4. There can be 4 flips of a coin. This random variable can have 3 flips of a coin, which is a head. So what are the possible values this little capital X can take? 5, 4, 3, 2, 1, 0. So this whole information basically talks about the whole of sample space here. So that's why random variables are very, very important and make our life more simpler. I'm just giving you a very simple way of looking at it. Okay. Now let's look at types of random variables. Okay. So let's go forward. Now, a type of a random variable. Now, discrete random variables and continuous random variables. If you remember very early, we talked about variables. It's a characteristic of a population, if you remember that definition. And now we are going to say this variable we have, characteristic, is not random. This randomness comes up as like, we are trying to quantify a variable whose values depend upon chance. And remember the previous slide, we talked about a variable. This random variable was the number of heads in 3 flips of a coin. What happens over here? When I do 1 flip, 2 flip, when I do 1 flip, I do not know what is going to show up. It can be a head or a tail. Either one of that can happen. So that's a chance of a head coming up or a chance of a head not coming up. And then when we have all possible scenarios, we randomly pick up some of the outcomes of that flipping of a coin. And when you look at the sample space, we says every possible values which can come up. Now, discrete over here says that we can actually easily count those values. For example, this 3 flips of a coin, okay? We say let x, we said, is the number of heads in 3 flips of a coin. So what happened? What are the values my x can take? Now here my x can be, it can be 4, 3, 2, 1. No, sorry, it's going to be 3, 2, 1, and 0. So here, how many times the head pops up? It can be the 3, it can be 2, it can be 1, and 0. So it exactly is taking some finite values. There is an example which we'll be doing later on, is called a binomial random variable, which is called a discrete random variable. And then we were going to talk about if you have a random variable which is discrete, its probability distribution function is called a discrete probability distribution function. Okay, so these things will be talked in a few minutes, but just to get you in our heads on what we are doing here. And now let's look at a continuous random variable. So what is a continuous random variable? The continuous random variable is a random variable which takes values in a given interval. So example would be a normal random variable. Let me give an example over here. Suppose you are a manager of a store and you like to study how, how many, how many people are checking out in the lanes, and you want the, there should not be kind of a little backlog of people waiting to get their, groceries and stuff like that. So you would like to have the shortest possible time for people to, be in the lanes. So what you're going to do is, like, you would like to do a study on that and say how many lanes should be opened up so that there is no people waiting, and people can quickly do their groceries and leave. So you would like to check out the time. That's an example here of a continuous. You'd like to look at the time spent at the checkout. The checkout lane in a store. So time, we all know, we cannot say like somebody is coming, like some people would just spend 1 minute because there is less groceries to pick up, or somebody say has a lot of groceries or a lot of stuff they have. I'm just taking a store, which is say a grocery store here. So you can't exactly say fixed time. So what you do is, when you look at a variable where you're looking at the time spent, we say, hey, in this 5 minutes interval of time, say 5 people were able to check out, or because there was so much of rush or things, or only 2 people were able to check out in that lane. So those kind of things basically are going to be called continuous random variables. So the probability distribution function of a continuous random variable is called the continuous probability distribution function. We will be talking about this continuous random variables in another session. But at this point, I'm just giving you a big picture. Is when you look at a random variable now, not a variable, it's a random variable, because the variable is a scenario where it's a variable whose value is depending upon chance. Chance is the probability of that event happening or not happening. Okay, so we talked about 2 kinds of random variables. One is discrete, one is continuous. Now we're going to look at, we talked about probability distribution. Say, what is a probability distribution? She's been talking about it. I'm not getting it. So here's the one on probability distributions. So the next slide says, a probability distribution, or a distribution of a random variable, consists of 2 things. Not only tells us what the possible values a random variable can take, but it also gives us a list of the probabilities of those possible values. Well, let's go back to that example we had, 3 flips of a coin. Okay, so once again we go back to this one. We say, hey, X is the number of heads in 3 flips of a coin. Okay. So what was the sample space, and what were the values your X could also? Let's start with sample space. The sample space literally was triple H, HHT, HDH, THH, and then we had THT, then HDT, then we had TTH, and triple T. So based on our sample space, we said the capital X, these are the possible values. I'm going to write it down over here. Okay, so the first one is possible values. So possible values. So the first possible value is the number of heads. There are only, all the time you make a 3 flips, every time you get as a head. So the possible values is 3. So what is the probability of getting 3 heads? So the probability of the possible values. Oops, it's a little messier, so let me clean it up, guys. Okay, I'm going to take a little extra space over here and show you. Okay, so let's write this one. So here are the possible values of x. Now remember, we said it's a random variable. That means a random variable will have some possible values. And if we add to these possible values the probability of each of these possible values, so together it becomes a probability distribution of a random variable. That's what it is. So probability of possible values. Okay, possible values of x. When I say x can be 3, that means the number of heads in 3 flips of a coin. So when we have those 3 flips, every time we get is a head. Now, what is the probability of getting 3 heads? Now, look at what are the all possible scenarios. Remember, probability is the number of favorable events divided by the total number of events. So the probability of getting, so how you write this one is probability of this capital X being a 3. Okay, what is this probability? The probability of this X is what? It's only H. There's only one possible way we can get a head. So the probability is 1/8. Suppose when you throw a coin 3 times or flip a coin 3 times, you only get twice you got the head. How many possible scenarios? 1, 2, 3. So what's the probability that your X, this number of heads is 2, is 3/8. Okay, now if there is only one head, and how many possible scenarios is the probability is? 1, 2, and 3. The probability when this random variable only had a 1 head is again 3/8. Now, there is a scenario where not a single head appears. That means the possible value is 0. So what's the probability that not a single head appears? It's again 1/8. Okay, so that's what the probability distribution is of a random variable. It simply says a random variable is a variable where it will quantify the variable, and these variables are being quantified depending upon the chance of these basically occurring in that study. And not only tells us what are the possible values, but it also gives us the list of those probabilities of all of these possible values. So that is called a probability distribution. So very thing, once again, I'm going to repeat it. The probability distribution, or we say sometimes distribution, of a random variable consists of 2 things. The first thing, what are the possible values that random variable can take? Second, the list of the probabilities of those possible values. Okay, so we did the little example over here, and we're going to do a lot of examples, don't worry. Now let's look at what else it says. So I'm going to go back. So now here are furthermore some characteristics, very important. And this statement says that the probability distribution of a random variable, it assigns a probability to each value of x. So if it is assigning a probability, we go back to the probability chapter and remember that the probability when it is assigned to each of these values, possible values of x, that little capital X or small x here. So that means this probability that capital X is little x. Now this little x, guys, is this. It can be 3. It can be 2. It can be 1. It can be 0. Now here when it says the probability, now we go and take over the meaning of a probability. Probability means that it was always going to lie between 0 and 1. Remember that. Between 0 and 1 is the value of the probability. In other words, it's a proper decimal. Then the other thing is, the sum of all these probabilities for all possible values is going to equal 1. Now what we can relate it back to what we did, that means the probability of the sample space, remember, is 1. Now, when we come back to this experiment here, let's look at this one. These possible values of x, that random variable 3, 2, 1 and 0, each one of them is basically related to one of the outcomes in the sample space. So basically these 4 possible values are taking control of every possible outcome in the sample space. So we all know that the probability of sample space is 1, which simply says that the probabilities of each of these possible values are over here. So what does it tell us? That the probability of each one of them, when you add all these probabilities, it should equal 1. This is what it's saying. It says that the probability of x equals 3 plus probability x equals 2 plus probability x equals 1 plus probability x equals 0 equals 1. Okay, let's do the math. So on the left hand side, probability of x equals 3 is what? 1/8 plus 3/8. That's probability when x is 2 plus when x is 1 again 3/8, and when x is 0 it's 1/8. So this is 1/8, this is 3/8, and x is 2, and this is here. So this equals to the right hand side, which is 1. Now let's do the addition on this part. What is it? 8/8, isn't it? The left hand side says 8/8, which is equal to 1. And we are done. So this slide, guys, is a very, very powerful slide. Okay, the slide number 6, very powerful. Okay, so this talks about the definition of a probability distribution. And it says, now the second paragraph is relating these probability distributions to the things we have learned in a probability chapter, because probability distribution includes not only the possible values the random variable can take, but also the probabilities of those possible values. And these two little bullet points are basically equating these probabilities in terms of what we have learned. Now here is the combination of a random variable with the definition of probabilities and probability distribution taken together. So all these 3 things are now merging, guys. Okay, now you would have asked a question, what is distribution? What is the need of a distribution? Okay, what does distribution means, guys? In very plain, simple words, distribution is of any variable. Here is a random variable. It can be represented with lists. We can represent this with charts or graphs. Now these 3 things, guys, we have learned earlier. In our early sessions, graphs like in terms of box plots, in terms of your pie charts, bar graphs, histograms. It's a way of showing your data set or your research study, whatever you're doing. Then we've talked about frequency tables, relative frequency tables, or mathematical functions. Now this is what we will be actually going towards in a distribution. Okay, so remember, when I talk of a distribution of a random variable or probability distribution, I can represent that in terms of a list. So in terms of a chart or a graph, that means those histograms and stuff we have talked about. Frequency table, look at this one, guys. It's kind of looking like a frequency table to us, kind of, okay? And some mathematical functions. So as time goes by, we will look at those mathematical functions, which basically represent a probability of a distribution of a random variable. So this, guys, is the theory part here in this session. Now I'm going to talk about examples of what we have learned. Okay, so let's start with the very first example. Here, let X stand for the random number of cups of tea your professor drinks each day. Yes, I love to drink tea. Kind of love black teas, all, herbal teas. I love to have that. So here I'm putting myself over here, guys, okay? So here X stands for a random number. So once I did an experiment and said, okay, let me look for a week, what I basically do. So what was the number of cups I had? And it was not even a week. I just did it for, 5 days. Because the max I would go is for 4 cups in a day. So what I did was, okay, I'm going to see how many cups and what's the probability of those happening. So this was some kind of a study I had done, and this is what I got. So I said, okay, number of cups, if I am having 0, sometimes I'm not in a mood, but that's a rarity. So that's why the probability of having no tea is 0.02. It's a very small probability. Then probability of having 1 cup is 0.05. Probability of 2 cups, 0.15. Oh yeah, you can see from that I really love teas, okay? Probability of 3 cups is 0.35 and 4 cups, 0.43. Yeah, 5 cups, no, that's too much. But I have had that. 4 cups, yes, I've had it. So here's the example of a random variable. As simple as that. You can try it on yourself. If you like to drink coffee, you can, try that experiment. It's fun to do something. So here's the table. Here's a random variable. And at the same time, I have given you, this is the probability distribution of this random variable. So X, what I'm looking at, is the random number of cups of tea I'm having each day. And this little table is giving me the distribution. Remember, the distribution is you can have a frequency table, you can have a list or a chart or a graph. So what we're doing is in this little list is I'm actually showing how many cups I have each day, and then what is the probability of having those number of cups. Okay, so I'm just using this to save my space. Otherwise, you could have written like this. This X, the capital X, is the number of cups, and these are random number of cups. So I would say 0, 1, 2, 3, and 4. And yes, this experiment was done on a pretty bigger scale, and randomly I would go and picked up some days, and that's how I got that. And then this second column, I'm basically saying what is the probability that this little x is small x, and this little small x, guys. So this is capital X, this is small x, this small x, the small x here can be 0, 1, 2, and 3. Okay, so this one is the capital X and this is small x. All x are the number of values it can take. So when your x, small x is 0, I had 0.02. That's the probability of having no tea. So probability of having 1 tea a day is 0.05. Probability of having 2 cups is 0.15. 3 cups is 0.35 and 0.43. Okay, now look at the fact is this a correct probability distribution? The reason is, the first thing you have to keep in mind is, notice, each of this probability here, notice, 0.02, 0.05, 0.15, 35, 43, each of these probabilities is between 0 and 1. So that means that's right. Now, because if it is a probability distribution, what else is going to happen? When I add this up, it should give me 1. Let's do the addition part. So 5, 3, so it's 8, 10, 20 here. So 2 goes, so we have 4 and 4, and so it's 0.1. Voila! What do we notice? Yes, this is the correct probability distribution for this random variable. And that's what the previous slide was. And I have told you that's a very, very important slide. It has a lot of information. So we have found that this was a random variable. That was what your professor did. Now let's say how we can apply problems here. Okay, here's it. What is the chance your professor has more than 2 cups today? So chance means probability. Okay, what is the chance your professor? So that means the probability. This chance means probability. And what is the event happening? The probability that the capital X is more than 2 cups. This X, guys, is equal to more than 2 cups. That's my event. Remember, probabilities are we're looking at the events. What is the probability that might happen? It's more than 2 cups. So that means, what is the possible scenario? Either that can be this probability that X is 3 cups a day, or it's 4 cups a day. So what does this mean? Probability that capital X is 3 plus probability capital X is 4. So according to the formula, what is it? 0.35 plus 0.43. What do we get here? 0.78. Okay, that's the probability of having more than 2 cups today. What's the next question? Next question says, what is the chance that the professor has at least 2 cups tomorrow? Okay, so at least, that means the minimum the professor is going to have is 2. Well, there's a possibility of her having 3 or her having 4. How do we do that? So how do we write this one? So let me read it this way. So this probability, now remember, chance means probability. So I'm basically reading the sentence and breaking it down into smaller parts. So this X, the chance, is probability. What is my random variable doing? My random variable is at least 2 cups. What does that mean? Probability X is 2 plus probability X is 3 plus probability X is 4. So, which is what? I'm going to use a different marker here. Let's expand this one here, nicer page. 0.15, 0.35, 0.43. Okay, which is what? 0.93. Okay? Okay, so that's the probability of your professor having at least 2 cups tomorrow. Now, let's look at an example from a different perspective. So the next one is talking about things we all like to do. Right now, we would like to be healthy, do some exercise. Exercise can be walking, exercise can be running. So here I'm taking an example of walking. Okay. So the problem is, Dippy walks at least an hour 3 days a week. She walks for all the 3 days 80% of the time, 2 days 10% of the time, 1 day 6% of the time, and no days 4% of the time. Okay, 1 week is selected at random. So this is a nice little word problem, okay? This word problem is talking about walking at least an hour 3 days a week. And randomly a week was selected, and then they observed how many times, the walking was done. So they found that 3 days she's walking 80% of the time, 2 days 10%, 1 day 6%, and blah. So now we're going to use this as a word problem and we're going to translate into what we just learned. So in our learning, we are looking at, the first question is, define the random variable x. What is really going on over here we need to figure out. Okay, let's write this down. Okay, so here, this x, the random variable, it is, so notice the second, how many days she walks? 3 days. She walks 2 days, she walks 1 day, or sometimes she doesn't walk any day. So what are we saying? It is the number of days the walking is done. So the random variable is equal to, or you can say is, whatever we want to write, is the number of days. Who's a person here? Dimpy. The number of days Dimpy walks in a week. Because that's what we're doing. We're looking at how many days she's walking. Okay, let's look at this one. In a week, she can walk 3 days, 2 days, 1 day, or no day. So what are the numbers? 3 days she's walking, 2 days she's walking, 1 day she's walking, and no days she's walking. Now let's look at the probability that this x is x. Now this x, small x, is this guy's 3, 2, 1, 0. Remember, the possible values that your random variable can take is represented by the small alphabets. Okay, so this small alphabet x, so here means probability capital X is 3. Okay, so what is the probability? Now when we read the problem, remember percentages 80% of the time. You replace the percent into a decimal. What is 80%? 0.8. Okay, so this equals 0.8. It says 2 days 10% of the time. So 10%, because when you write it down probabilities, we always do probabilities in terms of decimals. But when we write it down, the analysis, we write in terms of percentages. Okay, so this is 10%, which is equal to 0.1. So probability when x is 2 is 0.1. Then 1 day, she's walking 6% of the time. Probability x is 1 is 0.06. And no days 4% of the time. Very consistent. Very good. That's a good sign. X is 0 is 0.04. Now notice when we are given a table like this of the probability distribution, and we say, is it really working according to the conditions? The condition is each of this probability has to be between 0 and 1. You notice each one of them is between 0 and 1. Good, that's taken care of. Another thing is that the sum of these probabilities should be equal to 1. So let's do the math here. Let's add this up. What's the sum, guys? Because remember, sum, the probability, the sum of the probabilities. Okay, let me literally write the sum of probabilities is equal to 0.8, 0.1, 0.9, then 0.96, and then 1. So this distribution is exactly a probability distribution because the two most important conditions are being met. Okay, that was an example of exercise, walking. Okay, now let's go and look at a different kind of example. Okay, here's a karate teacher, guys. So, a karate teacher would like to know what percent of his students will be able to break 2 boards. Now, the karate teacher has already done, he's a good statistician, we can see that. So, as a statistics person who really has a good knowledge about it, he says, yeah, you're doing good. So, he wants to see that, so he was able to do the math, somehow he forgot if there were 3 students, what would be the percentage? But then he remembered that, oh, I have created a probability distribution of my students able to break 2 boards. Based on that, he knows his math, his statistics, His statistics, he is very clear. He knows that this sum, so this guy's is capital X, by the way. He knows the sum has to be 1. This sum, when added, all the elements added, the sum here should equal 1. We know that. Now that's where he knows, so he says, okay, even I had forgotten what was the probability, I can just easily do my math. So according to him, what is the probability? The sum. So the sum of all probabilities, which is probability that x is 0 plus probability x is 1, probability x is 4 is 1. Okay, now let's literally write it down. So what does that mean? It means when probability x is 0 is what? 0.05 plus 0.2 plus 0.15. Now let's let this little 1, 3. Let's make a smiley face, okay? That's what I'm saying. Hey, this is my smiley face which I have to find. Plus, that means I'm just continuing with this one. So this is 0.05, x equals 0, x equals 1, blah, blah, blah. And then 0.15 equals 1. I want to find the smiley face. Smiley face is basically the percent of students who would be able to, so these are 3 students, and what is the percentage of 3 students able to break the board? So what is this? So 0.05 plus 0.2. So let's take out your calculators, guys. Go ahead. And let's do the math. So we find this is 0.55 plus my little smiley face equals 1. So what is my smiley face here? Make fun, guys. Do something which will help you and enjoy this class. So what do we find? It's 0.45. So this little thing, what is the percentage of 3 students able to break 2 boards? Is 0.45, because this total should equal 1. Okay? Okay, guys. Now let's look at some other kind of questions which can be asked on these kind of examples. Okay, let's move forward. We have completed the table because this is basically related to the information about your probability distributions. Okay. It says, define the random variable x. Okay, so what do you think is the random variable here? The random variable x, guys, is the number of, or the random number of students, because they are going to be randomly picked up. So is the number of students, and it's about the karate teacher, that will break 2 boards. Now if you are a karate guy, you know all these terminologies. Okay, now define probability of capital X equals X. So what it simply means is this. It says the probability, because this is capital P is the notation we're going to use for probability. Okay, that's what we are trying to equate it in this class. Okay, so capital P is probability. So we says this is, define this probability. So probability that the random number of students, or number of students, the random number of students equals this little x. The small x, guys. Okay, this small x can be, so number of students, the small x can be no students was able to break the 2 boards, or 1 student was able, or 2 or 3 or 4. It all depends upon how many students, if they are good students, they can do it. Okay, now it says find the probability that 3 students will be able to break the 2 boards. Okay, let's go back to the probability distribution table, guys. This is the number of students, and we actually found this in our previous slide. It's 0.45. The work's already done for us. So it is probability of, this little twiddle line I'm having. So that's what is the probability 3 students will break. This what basically I'm doing is 0.45. Okay. Now, the next question is, find the probability that at most, or you can write like this also. It is probability capital X equals 3. You can write like this too. Because remember, it's a number of students. That's how we define the random variable. Okay, if you really want to write down in sentences, that's what it goes. This little, or probability capital X equals 3. Now, find the probability that at most, that means the maximum only 2 students can break. So that means probability that capital X is less than equal to 2. Now, if you go back to our table, guys, how many possible scenarios? It will be 0, 1, 2. It can't be 3, it can't be 4. So it is either 0, 1, and 2. Let's go ahead and do that. So that's what it means. The symbol says at most. It either can be 0 plus a student has been able to break the 2 boards, or 2 students are able to break 2 boards. Okay, let's write it down. This is 0.05, 0.2 plus 0.15. What do we see? 0.4. That means 40% of the students can break 2 boards. That's good. Okay. Now, we are going to look at from a different perspective. And that is, okay, as I said, we are going to look at the mean of a discrete random variable. Okay, before I go deeper into all these words and sentences, okay, let me talk about something, guys, we have done earlier, and then I'll come back to all these things here. Okay, let's recall certain things. Okay, let's go back there. Okay, so this is a little recap, guys. Now remember, we have talked about mean and standard deviation. Do you remember that? Of a data set. Okay, now this data set can be a sample or it can be the whole population. So we have looked at mean and standard deviation of a data set earlier. We had one data set, say, representing all the heights of the students or the grades of the students. Or it can be, say, the walking done by a student, how many, the number of days the walking is done. Many ways of looking at what your research study is about. So here we looked at mean and standard deviation of a data set. Now, if you're looking at this one, now this data set, remember, can be a sample or it can be a population. That doesn't matter. The main idea is, what is the literal meaning of mean? What is the literal meaning of standard deviation? So what mean tells us? The mean, if you remember, describes the center or is the average value of a data set. Out of all those values on a data set, what is the average value which happens a lot? So this basically is kind of representing the average. Or it could be the center, depending upon what kind of population we're looking at. Now, the standard deviation is pretty obvious. This means the variability in the data set. Okay? So the variability in the data set, or the spread in the data set, or the how many far away the data values are in the data set, that's your standard deviation. So in that same manner, our random variable basically represents different values. It can take so many different values. So keeping this little thing in perspective, we can actually also find the mean value and standard deviation of a random variable. Now, random variable, remember we just talked about, suppose like as simple as flipping a coin. So that means my data set comprises of, if I flip a coin 3 times, I can either have 3 heads or I can have 4 heads, or not 4 heads, so not possible. Or we can have 3 heads, 2 heads, 1 head, or no head, That's my random variable. So it's a data set. My data set is basically filled up of, those heads and tails. So that means we would like to know or describe the random variable's probability distribution, where it is centered. Is there an average for it? So when you talk of a mean value and standard deviation of a random variable, this describes, guys, it describes the variable, that is the random variable. Let me write it as RV, okay, make my life simple. It describes the random variable's probability distribution. Okay, probability distribution, where this it describes where the variables, it describes the random variables probability distribution, I forgot to write this one, where the random variable probability distribution is centered, okay, and the extent to which it's spread around the center. And you say, okay, what does it mean here? Let's just look at this one. Suppose I'm going to use a dot plot over here, okay? So I had this, so this is, so suppose this is my center. That's the average here. So I have all these things happening, but most of the time, if I notice, this is where my values are coming. Okay, so that suppose is my sample mean. Let's look, right, this is my sample mean. Okay, so this is my sample mean. And when you look at, so suppose this is a random variable, this is representing some random variable. So each of these values are representing the value of that random variable. So this is the spread. You see how these data values are spread around the center. Just trying to make it do this, because all these data values are representing, say, some random variable. We do not know whatever it is. So the spread is called the standard deviation. So it's an analogy of things we have learned earlier, but now we are applying the same things. You'd like to know what is the center of this random variable's probability distribution. We're going to look at the standard deviation, or how much is the variability of this random variable around its center. Okay, so now let's go ahead and do the proper meaning and definitions here. So when we talk of a mean, our expected value of a probability distribution of a random variable. Okay, this is how we write mu. Okay, I'm having a population. Remember, mu represents a population. It's a population mean, or we call it an expected value. So this is expected value of the random variable x. It is given as summation little x are the values this random variable can take times the probability of each of these random variables, and we sum them up. Remember, this little capital X, this one, the Greek symbol, is the summation symbol. And so this mean is a weighted average of the possible values of this little x, and these weights are nothing but probabilities. That's the weighted average. Now, the values which are more likely to happen will have greater weight. If this distribution describes a population, that means the sample means of larger samples tend to be close to the mean, which basically the expected values are reflecting not what we observe in a single observation. Remember, this is probability. That means we expect that in an average, in the long run of observations, this is what is going to happen. Okay? So the sample means we are talking, so in other words, saying what we expect, because we are having a probability, we are quantifying probability. Keep those little things in mind. We expect for the average and long run of observations. The moment you see the word expect means mean, guys. Okay, now this is all theory. What we need to do is, how do we solve this if an example is given? Okay, let's do that. And I would like you guys to have your calculators handy. That's what we're going to do. I'm going to do it by hand, little steps, but after that, I'm going to go straight to the calculator, let it do my work, okay? So let's start with the same problem of your, the random cups of tea your professor has, okay? You know your professor loves tea. Okay, so here's it. We have an X, which stands for the random number of cups of tea your professor drinks each day. And this X adheres to the following distribution. Remember this distribution or probability distribution. It's one and the same thing. Just want to not write too much, okay? So this is, guys, remember, my probability distribution. Okay, the probability X equal to X means the probability that the random number of cups equals this little x. This little x, guys, keep in mind, is the value, the possible value your random variable can take. Okay, now we've already looked at this one. It says, what is the average? Okay, this is the different ways of asking a question. What is the average? What is the mean? What is the expected number of cups your professor has each day? Now, according to the formula, it says expected value of x is summation x times p of x. Okay, I'm going to do it one time to show literally how you do it by hand. And after that, remember, calculator, so that you will realize how thankful we are for the calculators to do the work. Okay, this x can be 0. So probability x is 0. Plus this x can be 1. Probability x is 1. Plus it can be 2. Probability x is 2. Okay, let's go further here. Plus 3, probability x is 3. Plus 4, probability x is 4. Okay, so what do you get here? Equals 0 times 0.02, that's simply 0. 1 times 0.05 plus 2 times 0.15 plus 3 times 0.35 plus 4 times 0.43. Okay, let's see what we get, guys. Okay, yeah, have you got your calculators? I hope you're plunging in the numbers. Okay, so if you notice, if you're plunging the numbers in your calculators, you would notice the answer is 3.12. Okay, guys, now that was literally doing by hand. What are we going to do? We're going to use calculators, okay? So what I want you to do is, now we're going to plug these ones in our calculators, these values. Now this one will go into L1, this one will go into L2, okay? Let's go ahead and get those numbers here. Take your calculators. Now stats, click on stat. By default, edit is highlighted. Press enter. Now if there's something in your L1s and L2s, clear them up. So go to L2, take to the top, press the clear button, enter. And now next go to L1, take it to the very top row, press clear, press enter. Please do not do the delete button. Do not. Okay, now let's plug in the values in L1. L1 would be the values of number of cups. We have 0, 1, 2, 3, 4. So we have 0, enter, 1, enter, 2, enter, 3, enter, 4, enter. Now take the cursor to the next column. L2 is 0.02, enter 0.05, enter 0.15, enter 0.35, enter, and 0.43, enter. So now we have got L1 and L2. Let's go and click once again on Stat. Now take the calculator to Calc. By default, one variable stats is highlighted. Press enter. List L1. Now go to frequency list and write L2. In order to do that, you see this number, press second. Where's the second? And then number 2. That's where you see this little, on top of that, this little blue thing, L2. That's what we need. So L2. Now take your cursor keys and take the cursor to calculate. Press enter. Oops. Okay. I must have made some mistake. Let me check the values. Okay, because sigma x should be 3.12. Something's wrong here. Let's look at the stats. Did I put them correctly? Ah, there you see my mistake, guys. That's 0.5. No, it should be 0.05. Okay, because remember what we did by hand should exactly be shown by the calculator. So that means if you get mistakes like that, go back and make sure that you have input the correct values. So I'm glad it has happened. So that way, if there's mistakes, make sure you double check. Okay, so we check 0.05. Okay, now I know it's not going to be a mistake. Let's go back and do it again. Stat. Take to calc, one variable stat, enter it. Most of the things are done. Just take the cursor to calculate. Press enter. Whoops, we got what we're looking at. That sample mean 3.12. Okay, now here we are assuming that we are having a population. So it's not going to give us this little capital XX. It's always going to give us sigma x. So make a note of that, the 0.972, because shortly I'll be coming back to this one. Okay, so what did we find here? We found that the sample mean, or the average for this probability, the mean of probability distribution. Guys, I'm going to take short forms. So PD means probability distribution. RV means random variable, okay? So this is probability distribution. Every time I'm going to use the word PD, that means I'm talking probability distribution here. So the mean of the probability distribution is that x bar for us, which is 3.12. And also keep in mind, it gave us that sigma x. That means we are talking of the standard deviation, which we will do shortly. But I still want you to keep in mind, note that 0.972. Okay? Okay, now let's try another example. Okay, here's it. A men's soccer team plays soccer 0, 1, or 2 days a week. Okay, here's for the sports fan. Now, it says the probability that they play 0 days is 0.2, probability that they play 1 day is 0.5, probability that they play 2 days is 0.3. We would like to write down the probability distribution. This little x, guys, is capital X, little x. Okay, remember that. And this one is probability x equals x. Just short form I'm doing, okay? So, but this is literally what it means. That little x means the random variable, which is basically the number of days our soccer team plays. That's what it is. If it plays 0 days, what is the probability? 0.2. You're playing 1 day, that means it is 0.5. You're playing 2 days, it is 0.3. Okay. Now, what is the long-term average or expected value of the number of days per week for the men's soccer team player? It's very easy. We can actually do it by hand here. So what we're going to do is we say, okay, mu is that formula, remember? It is summation x, probability x is x. So this x can be 0, 1, 2. So it's 0 times 0.2 plus 1 times 0.5 plus 2 times 0.3. Okay, what are the numbers? 0 plus 0.5 plus 0.6. When you add this one, 1.1. You can test it with the help of your calculators too. It will give the same answer. Okay, now let's look at an example from a very different perspective. It's from the people who love to play cards, and you're going to look at that one, okay? And if you love to, play with the help, sometimes we like to just play with money. Yeah, sometimes, just cents or little, quarters. So we might look at that way here. Here's the question. It says, you are playing a game of chance in which 4 cards are drawn from a standard deck of 52 cards. You guess the suit of each card before it is drawn. Now, once you take the cards, you replace back every time on each draw. Now, you pay $1 to pay. Okay, here's it. That means you give the money. That means it is going out of your pocket. Now, if you guess the right suit every time, you get your money back, and not only that, you make $256. Wow! Now, we would like to know what is the expected profit of playing the game over a long term. Okay, now you think, what is the question asking? Here's the clue. You see the word expect, you see the word mean, you see the word average. So basically, it says mean of this probability distribution. Okay, how do we look at this? So what is the random variable we have? The random variable is the amount of money you profit, because it's talking of expected profit in this game of your cards you're playing. What are the x values? The value is this amount of money. Either you're going to lose $1, that's -1, or you will get $256. Because every time you guess the right, you get your money back. That means you not only get your $1 back, but you also have $256. Do you see that? So basically what you paid, you get that back. So that's kind of, the deal is like, okay, you go give whatever you give, you not only get that back, but apart from that, you get $256. So basically you're making the profit is $256. Now, what is the probability? Now, in a suit, we know there are 4 cards drawn at a time. So the probability of guessing the right suit each time is, like the first card you make through is, that is only 1 possible out of 4 possible. So this is a probability problem, so which is like 1/4. So this is the first card in the suit, the second, the third. So basically when you multiply all the 1/4, because each time you pick the right card in the suit, you're basically, it's going to be, it's only 1/4 the probability of getting that right. So what is the final probability is 1/256. So what is the probability? It's 0.0039. Now, this is the probability of guessing the right suit each time. Now, the probability of losing is, that means the probability of always, and when you make the guess, it is 1. Remember the sum of all the probabilities is 1? Because there are many different ways you can lose. You said the right suit the first time, but after that you said the wrong terms. So what is the probability of losing? It is 1 minus 1/256, which is 0.9961. There are many various ways we can actually not make the correct guess. So what's the probability distribution going to look like? So this one, guys, remember, is capital X equals X, and this is probability capital X equals little x. Okay, the expected value, so the x can be either -1 or 256. This is look at the random variable is the amount of money you make a profit. So either it is you lose the money, because you remember when you play the game, you have to put in $1. And if you guess the right suit, you win. But if you are not able to guess the right suit, you totally lose that money. On the other hand, if when you start the game, you pay in $1 and you guess the right suit. The probability of guessing the right suit is given 0.0039, But remember, what happens is, if you guess the right suit, you not only get your money back of $1, which you started to play the game with, but you also get $256 back. So what is the expected value? Remember, it is the mean or the average, so it's the mu. This is the expected value. Mu, remember, is summation little x and probability x is little x. This x is either -1 to 56. When you plug in the values, you get to be 0.0023 or 0.23 cents if you want to deal in terms of the units. So what it says is, on an average, you expect to win 23 cents for each game you play. However, each time you're playing, you either lose $1 or profit $256. So the 23 cents is the average or the expected win per game after playing this game over and over and over. Remember, it's probability. If you really want to get, so you play the games a lot of times, so in an average, that's what the results would be. Okay, then we talked about standard deviation, remember guys? Standard deviation of a discrete random variable. So the standard deviation of a probability distribution, which is denoted by this parameter, that means we are looking at a population, what we think is it's a population. It measures the variability from the mean or the center. So larger values of this sigma, which is the sigma, guys, this is the way we pronounce this notation, it corresponds to a greater spread. And roughly this sigma describes how far the random variable falls on an average from the mean of its distribution. Okay, let's look at the formula, guys. Here it is, guys. This is nice little complicated formula, guys, and I would like to say hi and bye to that. Because remember what I said, you're going to literally use calculators. When you want to find the standard deviation, we are using calculators. Get that? Okay? No ways, guys, I'm going to plug in the values over here and do all the work. Quite a lot of work, okay? So here's it. So remember the last time when I had this calculator in the session, and I said make sure we keep the notes. So I'm going to get that back over here. So what you do is you plug in the values, and what we happened was we did the one variable stat. Remember what was the standard deviation of this random variable? 0.972. Keep in mind, we are only going to use calculators to do this random variable standard deviations, okay? So 0.972 is the answer. Let's write it down. 0.972. And we are done. Let's make a little smiley face. Okay. Thank you, guys.